So today we discuss implement using node ROM to represent this function. So y1 equals x4 dash, y2 equals this x1 x3 plus x2 x4, x2 dash x4, y3 x1 dash x2, x2 x3 dash y4 x1 x2 x3 x4. So we need to implement this. So we need to implement the circuit using node ROM to represent the following conditions y1, y2, y3 and y4. So we have got four inputs. Obviously four inputs are there. x1, x2, x3 and x4 are the inputs, and y1, y2, y3, y4 are the outputs. So since there are four inputs, it is having 16 combinations: 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 2, 1, 1, 1, 1. So these are 16 combinations. Corresponding to this, you will be able to write the corresponding y1, y2, y3, y4. So y1 is x4 dash, so this is 1. So y2 is x1 x3 plus x2 dash x4, that is 0. So y3 is 0, y4 is 0. Similarly, for this combination of input 0, 0, 0, 1, the output is 0, 1, 0, 0, 0, 1, 0, 0. Correspondingly, 0, 0, 1, 0, you get 1, 0, 0, 0. And we are having the last output. Similarly, you will be able to write for all other combinations. So this is for all other combinations, your input and output is like this. So next step is how to implement this. So this is the four inputs, these are the four outputs. Next step is how to implement this. So this implementation is simple. So we want to implement this by using node ROM. So you have got four inputs and 16 output lines are there. Since there are 16 output lines, you must be having 16 word lines. So how to implement this? So this implementation is, so you have to draw four inputs. There are four inputs, and there must be 16 outputs. So there must be this device must be what? This device must be a 4x16 decoder. 4x16 decoder. So these are the inputs: x1, x2, x3 and x4. So corresponding to this, you must be having 16 decoders. 16 output is 16 lines. So you draw 16 word lines. 1, 2, 3, 4. Similarly, 16 word lines you will be able to draw. So this is the first word line, second word line, 16 the word line. So there are four: y1, y2, y3, y4 are the functions to be implemented. So that will be represented in 4 bit lines. So 4 bit lines, there must be pseudo NMOS connection. So there must be pseudo NMOS connection. So grounded PMOS is this. Grounded PMOS. So this is your supply VDD. So you draw corresponding bit lines. So there are 16 word lines and 4 bit lines. And in this interconnection of bit lines and word lines, you represent your patterns. So the first pattern is, we have seen this first pattern, and I have put something like this. So 0, 0, 0 is the input pattern. Correspondingly, there is 1, 0, 0, 0. 1, 0, 0, 0 means it's a node ROM connection. Node ROM connection means whenever there is 1 to be represented, there won't be a transistor. So there will be a transistor for representing a 0. So this is 1, 0, 0, 0. So this is 1. So there will be, this is there is this is 0, this is a 0, this is 0. And there must be a ground line. I am drawing a ground line in between, which can be shared by adjacent word lines. So this is the ground. So this represents what? This represents a 1, this is a 0, this is a 0, this is a 0. So the second line is for 0, 0, 0, 1 input, 0, 0, 0, 1 is the input combination, output is 0, 1, 0, 0. 0, 1, 0, 0 means the first line is having a transistor. First line is having a transistor. So this ground line is shared, this is 0. Then the next is 1, there won't be any transistor, then there is 0. Then there is 0. So this represents what? This is a 0, this is a 1, this is a 0, this is a 1. So 0, 1, 0. So you will be able to extend this for the whole 16 combinations. So that picture is this. That picture is this. So you see, these are the inputs. X1, X2, X3, X4 are the inputs. So this is connected to a 4x16 decoder. So 4x16 decoder is having 16 output lines. So those form the word lines. So this is the Y1, Y2, Y3, Y4 are the bit lines. So it's a pseudo inverse connection. Pseudo inverse connection. Since it is a NOR room, whenever there is a transistor, that represents a 0. So no transistor, it is 1. So this is the way that function can be implemented by using NOR room. So there's a picture. So thank you very much.